Greetings, guys. This is Anthony Dick with just some more examples from section 3.2 about operations with functions and specifically the difference quotient. But right now, before we get into difference quotient, I want to give a few more examples of just combining functions, specifically of combining domains. We did one last time. Let's look at another. Given this function, x over x plus 3, where the domain is x such that x can't be, or x is greater than negative 3, and I can see that comes from here, where it can't be 0 and it has to be bigger than negative 3, so that's not a negative number. And the function g of x is negative x plus 4, with the domain of g is x such that x can't be, x is less than or equal to 4. So here we've got two domains. Find the domain of the function f minus g of x. So I need to combine those domains. Now I'm going to show you again graphically, because I think this is the easiest way to visualize this. Here's my number line, all the way from negative infinity to infinity, and negative 3 is somewhere down here, and this says x is greater than negative 3, so it can't be equal to negative 3, and it's got to be greater than. So I'm going to shade everything greater than negative 3. And remember, when we're finding the domain of a function like this, where we're combining two functions, we're just combining the domains. And this says x is less than or equal to 4. Well, where's 4? Well, 4 is up here, and it's a solid dot there, so it's included, and it's less than or equal to 4, so it's everything smaller. And perhaps already some of you can see what my domain's going to be. So where do they intersect? In other words, where do they both hit? They certainly don't hit here. What about at negative 3? Well, the red one does, so this does, but not this one. So it's negative 3 all the way up until 4. See, it's double-crossed until I get to 4, and 4 is double-crossed. So there's my domain as an interval. In set builder notation, it would be x such that, and they're literally here, x is between negative 3, so it's got to be, negative 3's got to be less than that, or x is greater than negative 3, and it's less than or equal to 4. This is the way I do an in-between interval in set builder notation. I'd have the lower end, the higher end, and then I do less than, less than. This one's equal to, because it can be included. Okay? Now, when you're combining them with adding, subtracting, multiplying, and dividing kind of thing, whatever domain restrictions are going to happen in the parts will also happen in the combination. Kind of like we just saw with this one. This negative 3 is less than x, or x is greater than negative 3 that we had here, is still there. This x is less than or equal to 4 that we had there is still there. Okay? Now, when you're dividing them, you're going to have all the restrictions you started with in the parts, but you're going to have one more where you have to find the restriction of where the denominator is not equal to 0. And we saw that in the first few examples. However, look at these. F of x is x squared plus 1, and g of x is 2x plus 1. If I'm combining these, they have no domain problems. Okay? But what I want to look at with these is what happens if I combine them with some numbers. F plus g of 3. Well, this is telling me to find f of 3 and add it to g of 3, right? Because if it's f plus g of x, I would take f of x plus g of x. I could take this and take this, combine them all, and then put 3 in there. But it tends to be a little easier to put 3 into here. So this is 3 squared plus 1. 3 squared is 9. 9 plus 1 is 10. Plus, and then put 3 into g. If I put 3 into g, that's 2 times 3 plus 1 plus the 1. 2 times 3 is 6. 6 plus 1 is 7. 10 plus 7 is 17. If I'm evaluating them with numbers, I never actually have to find the algebraic function like we did before. I can just combine them with the numbers. B, f times g of negative 2. This is telling me to find f of negative 2 and multiply it times g of negative 2. So if I put negative 2 into f, f is x squared plus 1, so I've got negative 2 squared plus 1. Negative 2 squared is 4. 4 plus 1 is 5. G of negative 2 says take negative 2 and put them into here. So 2 times negative 2 plus the 1. 2 times negative 2 is negative 4. Negative 4 plus 1 is negative 3. 5 times negative 3 is negative 15. There it is. Okay, that becomes even a little bit more straightforward and frankly kind of a little more fun if I'm doing it with a graph or a table. So let me show a table first for a second. Here's my table of values from x and f of x and g of x. And notice that I don't have an equation. I don't need one. I've got the table. So let's look at all these. F plus g of negative 4. That's telling me to find f of negative 4 and add g of negative 4. Well, f of negative 4 says when x is negative 4, so that's right here, what's f? So when x is negative 4, f is negative 2. Plus g of negative 4 is saying when g is negative 4. When x is negative 4, what's g? Negative 4, that means I get a 1. Negative 2 plus 1 is negative 1. That's it. It's that easy, guys, really. Okay? F minus g of 0 is saying, well, let's take f of 0 and subtract g of 0. So let's go to my table again. F of 0, so I find where x is 0, and I find f of 0, that's 6, minus g of 0. So I find where x is 0, and then I find g, that's a negative 3. 6 minus a negative 3 is the same as 6 plus 3, which is 9. F plus g of negative 2. Well, that's just telling me to find f of negative 2 and add it to g of negative 2. It's just a page number. So I find where's x is negative 2 and f is 2 plus g of negative 2. So I find where x is negative 2 and there's g. G is negative 1. 2 plus a negative 1, that changes to a minus, and 2 minus 1 is 1. Okay? F times g of a negative 4. Well, that's just saying take f of negative 4 and multiply it times g of negative 4. What's f of negative 4? Well, find where x is negative 4. There it is. F is negative 2 times g of negative 4. So find x is negative 4. Find g. G is 1. Negative 2 times 1 is negative 2. And that's it. That easy. F over g of negative 5, well, that's just telling you to find f of negative 5 and to put it over g of negative 5. So I would go up to my table. There's negative 5. X is negative 5, so f is negative 4. So negative 4 over g of negative 5 means find x is negative 5 and then go to g. G is 2. So negative 4 over 2 gives me negative 2. And there that is. Now, that's how we look at it with a table. With a graph, we're really looking at the same kind of things. We just have to evaluate these pieces on a graph. Let me show you. With a graph. It says, given the graph, evaluate the following. And it's telling me to evaluate f plus g of 0. Well, f plus g of 0 is just f of 0 plus g of 0. Well, f of 0, if I put in 0, you know what? I never said which one of these was f and g, huh? So I'm going to say this is f, and this is the graph of g. Okay? So f of 0, I got to find 0 on the x-axis and find where f crosses it, right there. So this is equal to 0 plus g of 0. So I find 0 and I go down to g. There's g, and g it looks like is negative 2. So 0 plus negative 2 is negative 2. So the difference in these, when I'm finding these combinations, is instead of using a table to find my values, I need to use the graph. So f times g of 2, that's f of 2 times g of 2. F of 2, I'm going to go to 2, and I'll find f. That's right there. That's 2, right? So 2 times g of 2. G of 2, so I'm going to go to 2, go to where g is. That's right there. Well, that's at negative 2. 2 times negative 2 is negative 4. f minus g of negative 1, that's telling me to find f of negative 1 and multiply it times g of negative 1. Well, if I put negative 1 into f, there's negative 1. F is right there. Means it has a value of 1. So 1 times g of negative 1. If I put a negative 1 into g, that's right there at positive 1. Wait a second. Wait, I made a mistake. F of negative 1. Negative 1. Oh, that goes to negative 1. And negative 1 times 1 is negative 1. There we go. So there's my values of that. Next time we'll talk about a difference quotient, which is this basic thing in calculus. Okie doke. Thanks. See you next time.